We're now going to walk through an example involving the motion of a projectile. The height in meters of a projectile shot vertically upward from a point 1.5 meters above the ground with an initial velocity of 19.6 meters per second is given by the function h of t is 1.5 plus 19.6t minus 4.9t squared after t seconds. I graphed our function h of t over here on the right just so that you can see what's happening. The projectile starts 1.5 meters above the ground. That's right here. It goes up, and then it comes back down and hits the ground. We want to find the velocity after 1 second and then after 3 seconds. The velocity is the derivative of position, and our position is given by h of t. So let's write down that h is equal to 1.5 plus 19.6t minus 4.9t squared. Our velocity then is just the derivative, h prime, and that is 19.6 minus 4.9 times 2 times t. So this is just 19.6 minus 9.8t. I'm going to go ahead and highlight that because we're going to need that again. Now all we have to do is find the velocity at 1 second and at 3 seconds. The velocity at 1 second is going to be substituting in when t is 1. So this is 19.6 minus 9.8, and that is 9.8, and velocity is in terms of meters per second. Now we're going to find the velocity after 3 seconds. So we're just going to plug in 3 for t. So this is 19.6 minus 9.8 times 3. And this ends up being a value of minus 9.8 meters per second. Notice that the velocity after 1 second is positive and the velocity after 3 seconds is negative. So that means that at 1 second, our projectile is still going up, but at 3 seconds, our projectile is on the way back down. This leads into part B, where we are going to find when does the projectile reach its maximum height. And whenever you have the word when, that means you're going to be solving for t. Our projectile is going to reach a maximum height when the velocity is 0. If we look over here on our graph, it's going to be at this point right here where the slope is equal to 0 because the slope is the derivative and the derivative is the velocity. So we need to find t when our velocity is equal to 0. Our velocity function was highlighted up here in yellow, and it's 19.6 minus 9.8t, and we're going to set that equal to 0. So we have 19.6 is 9.8t. If we divide by 9.8, we get that t is equal to 2 seconds. At 2 seconds, our projectile is at its maximum height. Part C is a kind of a follow-up from that. Part C is asking us, what is the maximum height? The maximum height is going to occur at 2 seconds. So we need to find h when t is equal to 2. Let's go ahead and write our function for h. It is 1.5 plus 19.6t minus 4.9t squared. And now what we're going to do is we're going to let t be equal to 2. So this gives us 1.5 plus 19.6 times 2 minus 4.9 times 2 squared. If you plug all that into your calculator, you end up with 21.1 and that is in terms of meters. This means that the maximum height of the projectile is 21.1 meters. Let's look at the next question. This question asks us, when does the projectile hit the ground? When our projectile hits the ground, our position is going to be 0. So we want to find t when our h is equal to 0. So our h is 1.5 plus 19.6 t minus 4.9 t squared, and we're going to set that equal to 0. We are going to have to use the quadratic formula to solve for this, and you can think of the quadratic as at squared plus bt plus c is equal to 0. So t is equal to minus b, so that's minus 19.6, plus or minus the square root of b squared, so we have 19.6 squared, minus 4 times a, which is 1.5, times c, which is minus 4.9. You have to be a little careful with the negatives. And we're going to divide all of this by 2 times a, which is 1.5. If you put that into your calculator, you end up with two values. T is minus 0.08 seconds, and then 4.08 seconds. We know that time cannot be negative, so we're going to put an X through that solution. And that tells us that the projectile is going to hit the ground at 4.08 seconds. We have one more question. The question is, with what velocity does it hit the ground? So we want to find the velocity at the time when it hits the ground, and that time is 4.08 seconds. So we want to find v when t is equal to 4.08 seconds. Our velocity function was 19.6 minus 9.8t. So all we have to do is substitute in that t is 4.08. So this gives us 19.6 minus 9.8 times 4.08. If you put that into your calculator, you end up with a value of minus 20.38 meters per second. It makes sense that our answer is negative because our projectile is traveling in the downward direction when it hits the ground.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.